Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P16F5 indicates a high voltage situation in the starter cut relay 1 control circuit. This is a crucial issue since the starter cut relay is responsible for engaging and disengaging the starter motor based on signals from the powertrain control module, PCM. When the vehicle is turned on, the relay controls the electric flow needed to start the engine. If the voltage in the circuit is too high, it can lead to the starter continuously running or failing to operate properly, which may prevent the engine from starting altogether. Understanding this DTC helps in identifying potential problems in the starting system and allows for targeted repairs rather than trial and error-based fixes. Therefore, it's essential to correctly diagnose and address this issue to maintain vehicle performance and reliability. The DTC P16F5 directly refers to the high voltage in the starter cut relay 1 control circuit. The starter cut relay is situated near the engine compartment within the relay circuit board, connected to the PCM. The PCM, or powertrain control module, plays a pivotal role by sending the necessary signals to engage or disengage the starter relay as the ignition is turned on. For the system to function correctly, the voltage in the circuit must be within specified limits. When this DTC is indicated, it suggests that the voltage exceeds the acceptable level, which may cause malfunctions in starting the engine. This could lead to either a no-start condition or potentially damaging the starter system components if not addressed in a timely manner. Understanding the possible causes for DTC P16F5 is crucial for effective troubleshooting. A faulty relay circuit board may be the primary reason, where internal failures prevent the relay from functioning properly, resulting in high voltage readings. Wiring issues are another significant factor. A short circuit or damaged insulation in the starter cut relay 1 circuit can lead to excessive voltage. Furthermore, problems with the PCM could also contribute to the high voltage condition. If the PCM improperly handles the signals sent to the relay, it may mistakenly allow a higher than normal voltage to pass through. Each potential cause must be thoroughly investigated to ensure an accurate diagnosis and appropriate repair actions. When DTC P16F5 is present, several symptoms can manifest in the Honda Accord. A primary symptom is having no engine start, as the starter may be receiving incorrect signals or insufficient power due to the high voltage condition. Additionally, users may notice unusual behavior from the starter motor, such as it running continuously or failing to engage at all. Drivers may also find that the vehicle displays additional DTC errors, indicating problems with the starter system. Monitoring these symptoms can provide valuable information, enabling technicians to narrow down the cause of the problem quickly and accurately. Documenting these observations enhances the troubleshooting process considerably, allowing for more effective repairs. The first step in troubleshooting DTC P16F5 involves verifying the problem through a series of actions. Begin by turning the vehicle into the on mode, which powers the electrical systems without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs, including P16F5. After clearing the codes, start the engine to check if the issue persists. This process will help determine if the DTC is confirmed or merely pending. If P16F5 appears again after following these steps, it indicates that the problem is currently active and requires further diagnosis. Conversely, if it does not appear, it may suggest an intermittent failure, prompting a check for poor connections or loose terminals in the related circuits. In Step 2 of troubleshooting DTC P16F5, begin by ensuring the vehicle is turned off and in the lock mode to safely access components. Next, remove the relay circuit board from its housing, as this allows for direct testing. Testing the relay is crucial in determining its operational status. Should the relay function correctly, the next step is to continue troubleshooting. If the testing confirms that the relay is malfunctioning, replacing the relay circuit board becomes necessary. This straightforward step ensures that any potential faults within this critical component are addressed before moving on to inspecting the wiring and connections. The third troubleshooting step for DTC P16F5 involves checking for potential short circuits in the wiring connecting the starter cut relay 1 to the PCM. Start by utilizing the HDS to jump the SCS or service check signal line and wait for more than a minute. Following this, disconnect the PCM connector A, which typically has 50 pins for communication and control. Next, power the vehicle to on mode while keeping the relay circuit board removed and the PCM connector disconnected. Measure the voltage between the specified test points on the PCM connector and the body ground. If the voltage reading is at 0.1 volts or less, the wiring is functioning correctly, and further troubleshooting or professional guidance may be necessary. However, if the voltage exceeds this threshold, it indicates a short to power between the relay and the PCM, necessitating repairs to that wiring. After completing repairs related to DTC P16F5, the final verification step is essential to confirm that the issue has been resolved. Begin by checking the HDS for any remaining active DTCs. If no DTCs are confirmed, proceed to conduct a functional test of the starting system. Start the engine to evaluate its responsiveness and performance. This will also provide insight into the functionality of the starter cut relay. Close monitoring of the starter's operation during this test is vital, ensuring that it engages and disengages properly without any uncommanded behavior. If everything operates as intended, with no additional codes, the repair process can be considered successful, ensuring vehicle reliability once again. To prevent issues related to DTC P16F5 from recurring, regular preventive maintenance is highly recommended. Start by routinely inspecting all electrical connections related to the starter cut relay. Ensure that terminals are secure and free from corrosion or dirt. Utilizing high-quality replacement parts during repairs is also essential to guarantee that all components perform reliably over time. After any work on the vehicle's electrical systems, monitor diagnostic codes periodically to catch potential issues early. This proactive approach can significantly reduce the likelihood of future failures. By being vigilant and performing regular checks, one can ensure the longevity and effectiveness of the starting system. In summary, understanding DTC P16F5 is crucial for diagnosing starter cut relay issues within Honda Accord models from 2017 to 2023. Following systematic troubleshooting steps allows for accurate identification and resolution of the problem, whether it lies in the relay board, wiring, or the PCM. Each step, from verifying the issue to replacing components, plays a vital role in restoring functionality to the starting system. Additionally, implementing preventive measures ensures that similar problems do not arise in the future, maintaining optimal vehicle performance. Ultimately, thorough knowledge and attention to detail when dealing with this DTC will contribute significantly to the reliable operation of the vehicle. Please like and subscribe to the channel. See you next time.